This is Techtinuum. Today's tech explained, tomorrow's tech revealed. This video is for educational purposes and not affiliated with any brand.
Picture Earth as a patient in rehab, slowly healing from decades of fossil fuel addiction. Solar panels and wind turbines are obvious prescriptions, but behind the scenes, scientists are deploying radical tech that feels ripped from a sci-fi blockbuster. Today, we're not just skimming the surface. We're getting into cutting-edge innovations battling climate change and asking the hard questions. How do they work? Are they scalable? And do the trade-offs outweigh the benefits? Strap in! This is where the future gets built. Let's start with carbon capture, the industrial-scale detox for our atmosphere. Traditional carbon capture systems outfit factories and power plants with massive filters that trap carbon dioxide emissions before they escape. The gas is then compressed and pumped underground, often into depleted oil reservoirs or porous rock formations, where it's locked away for centuries. But the real game changer is direct air capture, machines that act like high-tech air purifiers, scrubbing carbon dioxide straight from the open air. Some facilities mix captured carbon dioxide with water injected into basalt rocks, and thanks to a natural chemical reaction, transform it into stone within just a few years. The hurdle: these systems guzzle energy, with some plants using as much electricity as tens of thousands of homes, and costs remain steep. But innovators are slashing prices by pairing this tech with cheap renewables. The big question is whether we can scale it fast enough to make a dent in the billions of tons of carbon dioxide we emit every year. Now, let's talk about electric vehicles. They're the poster child for green transport. Zero tailpipe emissions, quieter streets, and instant torque. But critics point to their dirty secret: battery production. Mining the materials needed for these batteries can ravage ecosystems and sometimes exploits workers. The good news? Engineers are redesigning batteries to use recycled metals and less of the most problematic materials, while new breakthroughs promise safer, denser, and faster charging alternatives. And when an EV battery degrades, it's not trash. These packs often get a second life as energy storage for solar farms or factories. Studies confirm that even on today's grid, which still relies partly on fossil fuels, EVs cut lifetime emissions by well over half compared to gas cars. Now, imagine that grid running entirely on renewables. Suddenly, EVs look even cleaner. But what if cars could run on the most abundant element in the universe? Enter hydrogen fuel cells. Electric motors powered by hydrogen gas, emitting only water vapor. The magic happens when renewable energy splits water into hydrogen and oxygen, creating a truly carbon-free fuel. The upside? Hydrogen packs serious energy by weight, making it ideal for trucks, ships, and industries that can't easily switch to batteries. The catch? Right now, most hydrogen is made from natural gas, a process that still spews carbon dioxide, and fueling stations are few and far between. But some countries are investing heavily in green hydrogen, with massive projects aiming to produce it using wind and solar power. While hydrogen isn't ready to replace batteries anytime soon, it could be the missing puzzle piece for heavy transport and industry. Another unsung hero in the fight against climate change is the circular economy, a system where waste is designed out of existence. Imagine your old phone isn't dumped in a landfill but disassembled by robots. Its precious metals extracted for new gadgets. Advanced sorting systems can now process recycling far faster than humans, while 3D printing turns plastic waste into everything from furniture to building materials. Even the fashion industry is getting in on the action, with clothes made from recycled ocean plastic, plant-based leathers, and fabrics grown from algae. This isn't just good for the planet. It's a massive economic opportunity, with the potential to generate trillions in global benefits. And then there's the brain behind renewable energy: smart grids. The sun doesn't always shine, and the wind doesn't always blow. So these digital networks use artificial intelligence to balance supply and demand in real time. If your rooftop solar panels produce more power than you need, a smart grid can reroute the excess to a hospital or factory instead of wasting it. Pair this with massive grid-scale batteries, and suddenly, renewables become as reliable as fossil fuels, without the pollution. The fight against climate change isn't about one miracle solution. It's about a toolbox of technologies, each with its own strengths and challenges. Some, like carbon capture, are still rough around the edges. Others, like hydrogen, need time to mature. But for the first time in history, we're not just diagnosing the problem. We're engineering the solutions. The real breakthrough is collaboration. Governments, companies, and everyday people working together to turn sci-fi ideas into reality. So, is tech saving the planet? Not yet, but it's giving us a fighting chance. And in a race against time, that's everything. Which of these technologies excites you the most? Drop a comment below. And don't forget to like, subscribe, and hit that notification bell for more technology shaping our future. See you in the next video.
This video is based on available information and just a reminder is not an endorsement of any brand or product.